example, when HCl was dissolved in water, it was dissociated into hydrogen and chloride ion. Now the water molecule took this proton and converted into the hydronium ion. So all the hydrogen ions that are generated from the acids reacts with water molecule to form the hydronium ions in the aqueous solution. So according to this concept, base is a substance that ionizes in water to produce hydroxide ions. We read for the acids that acids are the substance that generate hydrogen ion, and now we are studying that the base is a substance that ionizes in water to produce hydroxide ion. Here is one of the example of a base that was when dissolved in water results in the formation of sodium ion and the hydroxide ion. As you can see here that in the aqueous solution of sodium hydroxide, we are having the water molecules, sodium ions and the hydroxide ion in that aqueous solution. Since there is an increased concentration of hydroxide ions in this solution when the sodium hydroxide was dissolved in water, therefore we will consider or we will identify this substance, that is sodium hydroxide, as an Arrhenius base. So now we will identify that which substances in the following reactions are acids or bases. In the first example, ammonium hydroxide when dissolved in water results in the creation of ammonium ion and hydroxide ion. Now we have read about the definition of Arrhenius acids and Arrhenius bases. Keeping in mind those definitions of Arrhenius acids and bases, we can easily identify that whether the ammonium hydroxide is an acid or base. As you can see in this reaction, the ammonium hydroxide results in the formation of hydroxide ions when it gets dissolved in water. Since it is resulting in the formation of hydroxide ion, therefore we will call this ammonium hydroxide as an Arrhenius base. In the second example, we have potassium hydroxide that was when dissolved in water results in the formation of, this is potassium, results in the formation of potassium and the hydroxide ion. So here you may observe that within the aqueous solution there is an increased concentration of hydroxide ion, and because of this increased concentration of hydroxide ion, we are referring this potassium hydroxide as a base here. So ammonium hydroxide and potassium hydroxide both are the Arrhenius bases. The substances as Arrhenius acid or as an Arrhenius base. First substance is that of nitric acid. We know that when nitric acid is dissolved in water, it results in the formation of hydrogen ion as well as the nitrate ion. Now, since there is an increased concentration of hydrogen ion in the aqueous solution, therefore we will consider this substance as an Arrhenius acid. Another example is that of magnesium hydroxide. We know that when magnesium hydroxide is dissolved in water, it results in the formation of magnesium ion plus hydroxide ions. Now, after this solution, Since magnesium hydroxide is resulting in the formation of hydroxides ion, so therefore this magnesium hydroxide is the Arrhenius base. Now we will discuss certain limitations of the Arrhenius concepts of acids and bases. First limitation of the Arrhenius concepts of acids and bases was that the Arrhenius definitions of acidity and alkalinity are restricted to aqueous solutions. We have read before that Arrhenius acids are the acids that when dissolved in water results in the formation of hydrogen ion, and Arrhenius bases are the bases that when dissolved in water results in the formation of hydroxide ion. So this means that in order to identify a substance as an acid or a base, we first need to dissolve that substance in the water. So if we have a substance which is not soluble in water, then we cannot identify that substance as an acid or a base. So this is the limitation of Arrhenius concept of acids and bases, that this concept is limited to the aqueous solutions only. Second limitation of Arrhenius concepts of acids and bases is that it doesn't explain the acidity of some compounds such as carbon dioxide, sulfur dioxide, as well as the basicity of ammonia. For acids, we read that there should be the generation of hydrogen ions. But for carbon dioxide and sulfur dioxide, we cannot predict that they would generate the hydrogen ion in the solution. Similarly, for ammonia, if we are considering it as a base, we cannot say that this ammonia will be generating hydroxide ion in the solution. But carbon dioxide and sulfur dioxide are considered as acid and the ammonia is considered as a base. So Arrhenius was unable to explain the acidity and basicity of these compounds. So these were the two limitations of the Arrhenius concept. And because of these limitations, a new concept to identify a certain substance as an acid or a base was derived, and we will discuss that concept in our tomorrow's lecture. Here is a multiple choice question from your review exercise. It says that which of the following cannot be classified as Arrhenius acids? The options are nitric acid, carbonic acid, carbon dioxide, and sulfuric acid. Now you know that nitric acid, when dissolved in water, results in the creation of hydrogen ion and nitrate ion. Since it is generating hydrogen ion in the solution, therefore we can consider it as an Arrhenius acid. Similarly, for carbonic acid, we may write that it, when dissolved in water, also results in the generation of hydrogen ion. Same is the case for sulfuric acid, that when it gets dissolved in water, it results in the generation of hydrogen ions. So this means that all these three options are related to Arrhenius acids. We are left with carbon dioxide, and we just read that carbon dioxide cannot be identified as Arrhenius acid since it doesn't generate the hydrogen ion in the aqueous solution. So, for this question, we have carbon dioxide as a right option. Now, we will study about certain uses of some common acids. So, we will first study the use of a common acid, that is the hydrochloric acid. This hydrochloric acid is used in the cleaning of metals and bricks. and it also removes the scales from boilers. Another example of the common acid is that of nitric acid, and this nitric acid is used in the manufacturing of fertilizers and the explosives. Similarly, we have sulfuric acid, and this sulfuric acid is used for manufacturing of different chemicals, drugs, dyes, paints, and the explosives. Another example of the acid is the phosphoric acid, which is used in the manufacturing of fertilizers and acidulants for food. These acidulants are basically the food additives that give sour taste to those foods. Here are some examples of common bases and their uses. First example is that of sodium hydroxide. The sodium hydroxide is used in the making of soap and also used in the drain cleaners. Another example of the base is the potassium hydroxide, which is used for making liquid soap and the shaving cream. Calcium hydroxide is used for making mortar, plasters, and the cement. And the last example of the base is the magnesium hydroxide, which is used as an antacid and laxative. And acids are used to reduce the acidity of stomach, and laxatives are used to reduce the constipation. So this was all for today. In tomorrow's lecture, we will discuss about the Bronsted-Lowry concepts of acids and bases. Thank you for being with me.